This kettle has several push buttons, and we'll need to simulate pressing those buttons in order to turn it on with our Arduino. First we'll need to press the power button, and then we'll need to press the temperature button in order to start the water boiling. We will do this by wiring both buttons to our Arduino so that it will be able to connect them to 0 volts momentarily. The first thing you need to do is make sure it's unplugged, as we'll be taking the cover off. There's 7 screws in total that we need to remove, and 2 of them are hidden under these little rubber feet at the bottom. The feet are really easy to remove, they're not glued in or anything, should just be able to pull them out. Once you've removed all 7 screws, the rest of the case is just held together with plastic clips. So you just need to slowly work along and prise it open with your fingers, and eventually it will come off. There you go, you can see the little clips here. And then it should just separate. This little chrome ring just pulls straight off. And there you go, that's the insides of the base of the kettle. You can remove the screen and button module. It does make it a bit easier to get to, but you don't necessarily have to do it. The easiest way is just to gently prise the bottom off, obviously being really careful because it's quite brittle, and then one at a time, and then it'll just come out. If you unplug it from the board, and then you can work on this separately. So looking at the back of the PCB, here's where we're going to solder our wires. You've got the power button on the left, you've got the LED backlight in the middle, and then you've got the temperature select button on the right, and then we're going to use 3 of the header pins on the right hand side, which is ground plus 5 volts and the heat signal. For the wires, I'm going to use 0.1mm 10 core multi-stranded cable because it'll be nice and thin, because we've got quite a few wires to fit inside. The first thing you want to do is tin all your wires. This will just make the next step really easy. And then just solder each one to the right place on the back of the PCB. Once you're done, cut your wires to about 6 inches long, and then just give them a bit of a twist so they tend to stay together, and then we're ready to solder them to the Arduino. The first thing we need to do is solder 2 pairs of header pins to the Arduino, and these are on pins 7 and 8 and pins 11 and 12. We'll need to put some insulation over the metal cover just to make sure that none of the pins on the board that we're going to attach short out. You can use electrical tape for this, but I've actually used a bit of extra thick duct tape. It's easier if we solder the wires to the logic level converter before we solder that to the Arduino. So start off with the power wires and make sure you use a different colour for the low voltage wire, just so we don't get them mixed up later on. Once you've done the power wires, solder the I/O wires to the board. But remember, the wire for the LED backlight doesn't go through this level converter board, so you need to leave that one free. Once you've soldered the wires to the level converter, you'll need to solder the level converter to the Arduino, and then solder the power wires. Make sure these go to the correct places, which is ground, V-in, and VCC. VCC should go to the low level side of the board, and V-in should go to the high level side. Finally, connect the wire for the LED backlight to analog 0, which says A0 on the board. I've actually soldered it to the digital 0 pin on this photo, so make sure you don't make that mistake. The one that you're looking for says A0. With everything wired up, we just need to mount the board inside the base of the kettle. There's a really convenient black plastic tab just where the power cable comes in. You can attach it to there, you can use hot melt or double-sided sticky, but it's probably worth maybe using Velcro or something if you need to take it out later on. Maybe connect the USB cable.